go. Okay, my name is Julie Lyderson. I am the Electronics Department Navigator. What that means is that I work with students to help them identify their program of interest, to then persist in that program and ultimately get to a point where they can secure employment in the field that they have trained in. We have 5-degree pathways, and I'll talk about all of that. And I just want to encourage you that this is being recorded. You'll be able to look back through these slides at your leisure. I've got about 20 slides. Some I will not pay much attention to, but you can look at those later. And if you have questions, it would be perfect if you would put those in chat. I will check chat periodically, and if I see it's a question that I'm going to be addressing in the course of this presentation, I'll just hold off on that. But I do encourage you to feel comfortable reaching out to me. I'm happy to have address questions by email, to schedule Zoom meetings if you want to talk it through. You can come in and meet with me in person, and I'll show you our labs. So here we go. And let's go ahead and we will move on to the first slide. So first, just to give you an agenda of what we're going to cover in the next about 38 minutes, I want to give you kind of that broad overview of credentials at North. Just very, very briefly, it helps to kind of understand the context of where electronics programs fit into the full mix. We'll zoom in on electronics programs in particular. We will talk about applied instruction because we are offering applied associate degrees and certificate programs. We want to understand what that means. We'll talk about the length of our programs or the pace at which you can complete various certificates and or degrees. And, whoops, just a moment here. Clicked on the wrong thing. There we go. And then we'll look at the job market and where do our employers, or excuse me, our graduates, where do they land in industry? Who is hiring them? What are the job titles? What kind of work are they doing? And what are the wages that they're seeing? So first, that big snapshot slide. I like to begin by defining the term college credential. When I say college credential in the context of this presentation, I'm just talking about a college certificate and or degree, and this is evidence that you have qualifications for specific skill competencies. There are also industry credentials, and you may earn some of those through the course of an electronics program, but for today's purposes, we're talking about college credentials, certificates, and degrees. And I like to reference here too, because some students coming to events like this are just kind of considering right now, is this going to be worth your while? Do you want to invest in attending a program at one of the Seattle colleges? And I think an important consideration when you're thinking about that is just to really look at the job market today and the job market, anticipated in the future, and recognize that there is a large portion of jobs. Right now, we're looking at about 70% of jobs in Washington State that do require some form of specialized training beyond high school. So I've listed at the bottom of this page some data source for that statistic and encourage you to kind of look into that. So it's definitely worth your while to be pursuing specialized training beyond high school education. And so now at North, as mentioned, we've got bachelor's degrees. We have 5 bachelors of applied science. Those are in early childhood education. They're in application development. We've got international business. We have got an international accounting bachelor's program. We have residential and commercial property management. And our newest bachelor's degree is a computer science, Bachelor of Science degree. We have several transfer degrees. So our Associate of Arts, Associate of Business, Computer Science. We have 3 different Associate of Science degree options, depending on your area of interest. We have an Associate of Fine Arts. So transfer degrees are really designed to prepare you to transfer to a 4-year program at another college or university. And it could be that it's moving you into a bachelor's program here at North or at another Seattle College District campus. And then we have career training certificates and degrees, and these are designed to prepare you for employment, and there are some transfer options built in. This is where electronics programs lie. We have applied Associate of Science degrees. We have 4 of those. We have 1 applied Associate of Science transfer degree, and it's a limited transfer degree, and I'll get into where that is intended to transfer. And then we have certificate programs. Our shortest certificate would take at least 2 credits, or excuse me, 2 quarters, more likely 3 quarters to complete. Most often our certificates take about a year of full-time attendance. And let me move into the next slide here. So the other thing before we really launch into the meat of it is that oftentimes when students are coming into North, they either have sort of a clear exposure to electronics, maybe as a hobbyist, or they are, pretty certain that they have an interest in studying electronics as a field. And then we have a lot of students who say, I really haven't had extensive exposure. Is this even relevant to career opportunities? And so I kind of like to touch on that right off the bat, and they're not even, sort of sure if they'd be interested in electronics. And so when I kind of brainstorm, where do we see electronics in our personal lives, in our careers, in our local area and globally, this is kind of the list of what I come up with. And when we're looking even just like at our basic needs, and food, clothing, shelter, that sort of thing. And we think about, well, how do we produce, how do we build, how do we distribute these things? Electronics comes into play in just about every case. Same thing for the way we communicate, how we receive our education, our entertainment, health and wellness, manufacturing, safety and security, transportation, space exploration, logistics, which is just kind of that movement of people and product from place to place. So it's pretty fair to say that electronics play a very prominent role in several ways in most of our lives. And I like to, at some of these slides, put a couple of things to keep in mind. And the first one is that, changing technology, as we know, it really impacts the way we live and the way we work and the work that we're doing, the tasks that we do in various occupations. So it's important to look at that and look at, emerging occupations that haven't existed in the past that are just coming into existence now. We know that robotics are actively in use. We know robots, artificial intelligence related technologies are capable of doing work that historically maybe was performed largely by people. And now we have these other tools that can accomplish this work, and they can do it, more safely or at lower cost or easier or more efficiently. And so it's just really important to consider that as you're considering your career training options. And I also included a link to a quiz that you can look at. It's just kind of an exploration of looking at different types of occupations and wondering, well, what is this a role that's likely to become more automated or not? And so just, Entry if you want to check that out, I encourage you to do that. So now this is a look at zooming in on the electronics department. You'll see we have 5 degrees. So listed in the left column, we've got our Electronics Technology Applied Associate of Science. We've got our Electronics Engineering Technology, and you'll notice that one is an AAST because it is a transfer degree. I'll talk about that in a later slide. We have this is the one with a very long title. It's called Healthcare Technology Management / Biomedical Equipment Technology. And for short, we refer to that as our biomed degree. We've got Industrial Power and Control. We have Mechatronics. And then we also have, there's this degree called IT Controlled Electronics, and that's technically housed in the IT department. I include it here because it includes about 8 classes that are electronics courses. And then on the right side of this chart, you'll see several certificates. These are certificates that are embedded in the degrees. And by that, I mean, it's kind of like the rungs of a ladder. You could complete our shortest certificate, Aviation Electronics 1, and then decide I want to build on that and work toward Aviation Electronics 2. And then maybe ultimately you say, I think I'd like to turn that into an associate degree, Electronics Technology. And you'll see several other degrees have certificates embedded as well. When I try to distill down, what are the key things I need to tell you about electronics while you're considering, might this be a fit for you? I've got kind of 4 categories. The first is that we are applied training programs. And that just means that we really emphasize hands-on application of learning. So most of our classes are going to have a model of lecture time in class, take a short break, and then move into lab. So you're getting the theory that you need through lecture. You're also getting these technical skills you're developing, and you're practicing them with a variety of equipment, which certainly is very much appreciated and in demand by employers. You are completing math that we're contextualizing for electronics. You also have this opportunity to, we frequently hire our students as teaching assistants. So this again is more application of your learning. So if a student completes a class and they had good success in the class and they enjoyed it, and they could talk with the instructor and say, hey, could I work as a teaching assistant? And it's a paid position, it's work experience. So something to keep in mind. We have a workforce focus with industry connection. So our programs are designed to prepare you for the workplace. And we're building our programs and reviewing, continually evaluating our programs in cooperation with industry and our technical advisory committees. Our instructors come from industry, so they have that practical work experience that students benefit from. We have internship opportunities. We've got that built into a couple of our degrees, but all electronics students and students in other departments as well are welcome to pursue internships. I'll share a little more about that on a later slide, but this is work-based learning and you can earn academic credit. Then we've got number 3. Another thing kind of specific to electronics programs is that there's a lot of opportunity to pivot between our different programs. So maybe you come in thinking, I'm going to do the electronics technology degree, and then you complete your first quarter and you start getting into the classes and you're talking with faculty, and then you come to recognize, you know what, I think maybe the biomed program or mechatronics is a little more aligned to my interests. So students have this opportunity to shift from one degree to the other, and that's because the core electronics classes, there are many core electronics classes that are required across all of those degrees, the same classes, but you still have this opportunity to specialize in your chosen area. And lastly, I think in the introductory session, I touched on just the value of this diverse learning community and the peer learning opportunity. The students who come into electronics programs come from a really broad range of backgrounds. We have students who are occasionally a running start student from high school. We have students who are working in industry and they come in because they're doing the work they want to be doing, but they really need to skill up. They're automating a production line and they don't have the skills for that. We have engineers who have extensive theoretical knowledge and they're here to gain hands-on, practical, applied experience. To make them a better engineer, or because they've discovered that, I'd really prefer to be hands-on. We have folks who have progressed out of our ESL programs and they've hit a certain level of English proficiency and they're ready to launch into electronics programs. And in many cases, students have had prior specialized training in electronics or a related field in their home country, and they're needing to get some additional training here and gain employment where an employer can really recognize the other skills they already have that they bring with them. So, and we've got career changers. They've worked in, entirely unrelated occupations or fields, and they're interested in pursuing electronics. Just to show you, kind of give you an idea where students are doing this work. So on campus at North, we have a building that's called the Education Building. All of our lectures and our labs take place in that building. We have 4 different labs. We're in the process of outfitting our 5th lab right now. That's going to be our designated biomed lab, but students will go to lecture, they'll, as I mentioned, take a small break and then move into the lab to apply what they've been studying. The top row picture you see on the top left-hand side, that's just a small, actually the side section of our main electronics lab where you see workstations where students are set up with power supplies, multimeters, oscilloscopes, core testing equipment. You see in the center upper picture, this is a FANUC, a small robotic arm. It's a picker sorter style of arm. The next right upper corner, that's a hydraulic trainer. Lower left, we've got our PLC, or programmable logic controller trainers. I think of PLCs as just kind of hardy industrial computers that are controlling a lot of different processes. The center lower photo is a former student she was working in our industrial power lab, where students are learning to work with high voltage safely. And then lower right, that's a photo of a motor. And moving on from there. So if we talk about pace of completion and kind of the logistics, when do you take your classes and things like that, starting with how long does it take to complete? So in our programs, students can begin any quarter, fall, winter, spring, or summer. Typically fall, winter, or spring is probably the best way to go. You can attend full-time or part-time. So if a student were attending full-time and they wanted to complete an associate degree, an applied Associate of Science degree, it's probably going to take them 7 or 8 quarters to complete that. If they're looking at one of our certificates, that's going to range from about 3 to 5 quarters to complete. And so as I mentioned, full or part-time, start any quarter. If a foundational math course is needed, that can add a quarter. So students have an opportunity. I'll talk about placement in a minute. But if a student comes in and says, I really don't want to take a placement test, and I just want to take a foundational math class, there's a class I can point them to, and then they can launch into electronics classes in the next quarter. Next one, important to talk about how credits work. So most electronics classes and most classes at North are 5 credit classes. A typical full-time student will take 15 credits. So they'll be taking 3 5-credit classes. That's in fall, winter, and spring quarter. Fall, winter, and spring quarter are all 11 and 12 weeks long. In summertime, if a student chooses to extend summer quarter, they don't have to, but if they choose to, it's only 8 weeks. So typically a student will often take fewer than 15 credits during summer quarter. Our associate degrees, they range from as few as 97 up to 111 credits. And our certificate range, we have the shortest certificate that's only 30 credits up to 68. And when do classes meet? So our classes are most commonly will meet 2 days a week, Monday and Wednesday, or Tuesday and Thursday. We do have some classes that we call hybrid classes. They meet only 1 day a week, but students are still have work to complete in place of a second class meeting, but they get to do that according to the schedule that works best for them. We don't have classes on Fridays, with one exception. There is a 1-credit soldering class. As I mentioned, most of our classes are 5 credits. So this is unique in that it's 1 credit. And whenever that class meets, students meet, typically it's on a Friday, and they meet for the first 4 Fridays of the term, and then the class ends early. So it's over early in the term. The class hours, we don't have any early morning classes. The common starting times for our classes are 11 a.m., 2:30, and 6 p.m. And that will vary from quarter to quarter. So some of our classes are offered 3 quarters out of the year, or there are a couple that are offered every quarter of the year. And then there are some that are offered twice a year, or maybe just once a year. So we build an academic plan with you to make sure that we're able to get everything to fit together well. Entry requirements. So if you decided, I think I want to get started with electronics, or maybe I'm not sure, but I want to take 1 class and get some exposure. This is what you would need to know. We want to see that students have placed into English 98 to get started in classes. Eventually, every student who's completing one of our longer certificates, which take about a year, or an associate degree, you'll need to take English 101. So sometimes students will take that right away. They don't have to. They could choose to take it later. When we build your academic plan, we can put all of the courses that you'll need into the plan. So if a student is coming out of an ESL program, we want to see that they have placed into what's called ESL level 5A. And this is assessed by the ESL department at North. And this is because the ESL level systems, it's different from one college to the next. So we want to make sure that you have completed ESL 4B, or you have been assessed and they've determined that 5A is your level. We don't want to see anybody at a disadvantage in the classes. And then math, we want to see that our students have placed into what's called Math 84 or Algebra 1. So all of the students need to be algebra ready to get going. And students can look at the college's testing webpage. They can take the general math placement test if they like. And we also have a test that we designed for electronic students. And the purpose of that pre-test is just to determine not how far in math can you go, but have you met the placement requirements? Are you, relatively comfortable with the math preceding algebra? And I get students access to that. So you would talk to me about that. So if, let's say you took a math placement test and said, we need a little foundational math first, you could enroll in a class that's called Math 81. And after that, completing that class, you would be able to directly enroll in our beginning electronics classes. So typically a student would start with a class called EET 109. That is our math for circuit analysis, and EET 161, that's DC electronics. That's the common starting place. Those are foundational classes that will be prerequisites for most of the later classes that you take. It'll also, they're very supportive classes to start with. And when you take 161, DC electronics, if you are somebody who says, I'm not really sure if I even enjoy electronics, that kind of exposure will really help you to answer that question, because it is a lecture lab class. So it'll be very hands-on. And a couple things to keep in mind. We want our students to make sure that they have some basic comfort with computers. Most of the time, our students are prepared with that and don't need any additional classes. If somebody feels like, I've had very little exposure to using a computer, they could take a class called Business 169 and get some familiarity, with Office for Windows. It's not required, but it's just a suggestion if you're feeling like, I think that might be helpful for me. And the purpose of placement, having placement requirements, is just to make sure that every student who is starting a program is ready to be successful in class. We know that our students are all here for that purpose. So we do not want to set anybody up with unreasonable expectations. And I am just looking in chat and making sure there's nothing there that I need to cover. So now, just briefly, I want to give you a quick overview of the courses that are involved in electronics. And as I mentioned, many of the same courses are going to be required for different degrees, but then you'll also have some more specialized courses. So DC or direct current and AC or alternating current electronics required for most of our degrees. Math contextualized for electronics required for most of our programs as well. There's one exception where more advanced math is involved. I'll show you that later. We've got a couple robotics classes. One is working with a small activity bot you're learning to program and configure. And one is larger industrial robotic arms, basic soldering, we've got fiber optics, PLCs, which I showed you a photo of earlier, hydraulics and pneumatics. We've got aviation electronics, known as avionics, and that's an example of a real specialized class. Most of our classes are designed to be broad-based to apply in a variety of industries. Aviation electronics is clearly very specific to aviation. Some core IT essentials focus on hardware and networking, some semiconductors, solid-state electronics, digital electronics, energy generation and conversion, learning about precise motor drives and controls, biomedical equipment. There's another one that's more specific to a certain industry. And to keep in mind here, heavy emphasis is applying what you're learning. So you might have a class where you have lecture for an hour and 20 minutes, take a short break, and then the next hour and 50 minutes is you're actually working in the lab. That's pretty typical for a class that would meet twice a week. And all of our degrees and our longer term certificates, like 1-year certificates, they're going to include some general education requirements. So every certificate or associate degree will require English 101. It will require an approved human relations elective course. If you're completing a degree, you will need to take a U.S. studies or global studies elective course. So there are some classes outside of the electronics program that factor into our programs. Internships, I mentioned internships, they're built into 2 of our degrees. Students who do the healthcare technology management or our biomed degree, they all complete an internship. It's in a hospital or a medical facility, medical equipment manufacturer, and that's typically in the student's final quarter. And our mechatronics students, they have the option of completing an internship to get academic credit for that if they prefer not to, or it just doesn't fit with their life schedule. They can choose classes from an approved list and take additional classes. The Boeing internship is probably the most popular for mechatronics students. We have many students who've completed an internship at Boeing, and those used to be just in the summer quarter, but now they're available every quarter. A couple things to keep in mind here. Any student can choose to complete an internship, even if it's not a requirement for their degree. Students do apply for their own internships, and we offer support in that effort. And if you're trying to receive credit for an internship, that's where a student has to enroll in an internship class. So in electronics, you would enroll in the electronics internship course. It's not like a typical course. It's going to involve things like keeping a work log at the site that you're interning. It will involve checking in with the faculty at North who's supervising your internship a couple of times during the quarter that you complete your internship. It may involve a final sort of a reflection or a paper about your experience, but it's not your typical time in class. Your internship class is performed on the job site at the workplace. And if you are completing a degree, we have 2 of our degrees that have a requirement of technical electives where there's flexibility in what you choose. You could choose to complete an internship to fulfill that requirement. Employers and job titles, and I'm just checking our times, going very quickly. We have about 10 minutes. Some of the employers that have hired many of our students or some of our students are listed here. Some of the names you'll recognize: Amazon, Boeing, Blue Origin. We're familiar with those, but then there are these organizations like BD Sciences. They do flow cytometry, and I'm not an expert at all in that, but they're analyzing chemical and physical characteristics of cells and particles. And they need electronics trained folk. If we scroll down to Directed Machines, they manufacture solar powered land maintenance robots. If you look at Helion Energy, they're up in Everett, and they are they're developing a fusion generators. They're all about working toward sustainable clean energy. Sinrad, they manufacture CO2 lasers up in Mukilteo. Thermetrics, they're over in West Seattle. And that's a really unique one. I learned it with just one student graduate there that I know of, and they make thermal measurement tools, and they create these mannequins that are used for testing. And one of the students that I know is working there is working on testing of high performance wicking fabrics, like used in athletics. And you can think about like the gear that firefighters wear. It's really important that that's safe and effective and in extreme conditions. So there's a lot of different places our students land. The job titles that they most commonly move into, I've listed those here. The key word is technician. They're usually moving into a position with technician in the title. Electronics technician is a really common one. And then the next 5 slides, which I'm just going to really very, very briefly mention, you can look back at these later. It's a summary overview of each of the degrees. It is a little statement about what makes it different from the other programs. So electronics technology, what's different from this one is that it includes aviation electronics, It includes advanced digital electronics, and it includes 2 technical elective classes, or you could do an internship to fulfill that requirement. And here's a summary of this. There are 3 certificates that build directly into this degree. So a student who says, I'm going to complete this degree will automatically receive those certificates along the way. We've got Electronics Engineering Technology AAS. This is the one that is a transfer degree. This class is very different from the others, this degree, because it includes several calculus classes, several engineering physics classes. If a student says, I think I want to pursue a bachelor's in engineering, this is something they might look at. What's great about this is you're getting this mix of the applied electronics classes, and you're taking those classes that will ultimately be required for any engineering bachelor's program. You have the option to apply to Central Washington University to complete their Bachelor's of Science in Electronics Engineering Technology. What differentiates it? The physics, the calculus classes, the ability to transfer, to apply to transfer to Central Washington. And this is a bit of a summary of that. Next, we have, this is our biomed degree with the long title. So students who are working with patient monitoring, diagnostic equipment, they're working in hospitals and medical facilities, medical equipment manufacturers. What's different from this degree? They take a chemistry course, a medical terminology course, a project management course, and the internship is a required element at the very end of their program. And here's a summary of that. And we've got mechatronics. We have about 6 minutes to go. Mechatronics is very unusual because it involves attendance at 2 colleges. So students completing this degree, it's offered in partnership with Shoreline Community College. So you will complete electronics classes at North, and you will complete classes in the manufacturing department at Shoreline. And mechatronics, the term comes from mechanics and electronics combined. It's sort of a field that combines several engineering subfields like mechanics, electronics, computer control systems, robotics, a variety of things. Oops, there we go. What's different about this? You're attending 2 colleges, not typically at the same time. Usually you'll start at one college, do the classes you required there, and then move on to the other one. There's an internship built in. You may complete an internship. You'd usually be at least a year into your program before you did that, or at the end of your program, or you could choose courses in place of the internship. There's a summary of that. And I know I'm going a little bit quickly, but I want to kind of get everything in here if we could. Industrial power and control is another one of our degrees. It's more about kind of control of large electrical currents and electrical mechanical systems. What's different about this, there's a couple of courses required that are unique to this degree that are actually also required for mechatronics. And summary of that, degree with a certificate built in. And then a little bit of employment outlook. I want to show you a couple of positions that encompass the skill set that our students gain through training at North. Electronics and electrical and electronics repair, avionics technician. I've listed the mean or the average salary. So this is including folks who are brand new to the position, as well as those who have a great deal of experience. You can see the data site listed below. So you can go to that website and look at Seattle King County data about look by different job titles and get this kind of information. Our graduates at North who get associate degrees tend to start at about $29 an hour. Our graduates with a 1-year certificate tend to start at about $24 an hour. The really important piece for students who are seeking employment is the ability to talk about their skills. Why should an employer hire you? So it's not just a matter of, look, I have this degree. That's a really critical piece, but also talking about what you've learned in your classes and in lab. And then we've made it down to about 3.5 minutes. So I've listed some of the frequently asked questions. If a student said, I don't know if I'm interested in this at all, there's 2 classes they could consider taking to explore that. One is a 2-credit Intro to Technology class called EET 105. We offer that fall and spring. Another one is called EET 161, DC Principles of Electronics. And that one's going to be very hands-on, getting you really into building circuits and working in our lab. Can you change your mind and shift into a different degree pathway? Yes, you can do that. I talked about that a little earlier because many of the same classes are required for different degrees. How do you know what classes to take? You talk to me. You can work with an academic advisor as well, but I can help you to build out your plan. That's a really critical tool just to help you efficiently achieve your goal. Most of our students are working, so there's that work-school balance reality for most students. Most of them aren't working in the field they'd like to be working in, but it's great if you have some flexibility in your scheduling. How many classes or credits are full-time? 12 to 20 credits is full-time attendance, as I mentioned. Most in Prof Tech programs, most electronic students are taking 15 credits per quarter. And will my degree transfer? When you see a class that has the and symbol, or what we call the ampersand, like English 101, that's a transferable class. So there will be classes within our degrees that are transferable, but there is one degree, Electronics Engineering Technology, AAST, that's designed to be a transfer degree. So that's different from the others in that all of the classes will transfer if you apply to and are admitted to Central Washington University's Bachelor's in Electronics Engineering Technology. But I think it's important to recognize you might need a human relations elective and you take Sociology 101, sociology with the ampersand symbol, it's a transferable class. So just because an entire degree is not transferable doesn't mean that there aren't classes within that program that are transferable. And since I think we're down to 1 minute, and I'm just back to this original slide so that you know how to contact me. Phone or email, even if you're thinking, I just don't know if I have any interest, I'd encourage you to contact me and we can talk on Zoom. You can come in, as I said, and take a tour. And I think that I've covered kind of the core things to give you a good idea what our program is all about, but coming in and touring our labs makes a big difference. And I would also encourage students to prospective students to look back at the page where I listed employers and I listed job titles and look into those employers and see what kind of work that they're doing and look at those job titles and you can look at, job descriptions for those titles and understand what is that work and might that be appealing to you. But I think we will be pulled back into the other group very, very quickly. So I will stop there and I hope thank you. I'm glad this was informative and feel welcome to reach out and thanks so much for your time being here. And I talk a lot up front with students and then not so much. So no worries about that. Oh, 40 seconds. Okay, and I don't see any questions in the chat, so I think we're good there. So you can select the leave breakout room and go back to the main room. They're going to meet for about 5 minutes and just to kind of wrap up tonight's session. Thank you.